sleeves. Me and Jack put our sleeves on.
Really? Yeah, Jack is.
Come on, ready?
Not now.
I kind of want to do that now.
Do it. How much did you spend on that?
3.
Do it.
$3.
Do it.
Oh, I hit you back. Very good.
Now your dad.
I have just the answer.
He did get a teeth fixed.
Yeah, every class.
No, 7.
Do it. No, do it right now. Where?
Yeah, no, do it. Season of square.
Where?
And your dad got his teeth fixed. I don't know how to do it. Oh.
Good enough to go there?
Hey, Connor, reach out.
Jack, I'm ripping the sleeves off.
Wait, hey, Connor. No, you should use
Jack,
we were making fun of Jonah, like all the girls he's dated.
Jonah.
And everyone's like,
No, sorry, this picture
be good.
yeah, without Jonah, it's going to be...
The one that you missed out on. And then I'm like,
I don't know how to smash this. Good idea. Really an action shot. Not you. My name's Connor.
I'll hold it down.
Jack!
Jack, you're awesome.
We use Seth's knife to get it open, and we
kept saying it's mine. Yeah, we're. Well, wait till Ward gets here. I'm gonna ask Ward.
I'm going to ask Ward if he has scissors.
He's probably done. Nick!
Maybe you deserve it.
His hands got pulled covered.
What'd you get?
That's fine.
Kid, I'll bust you.
I don't know how well I can.
You're so unspirited.
Bust you.
What? Ward.
I was sick. I didn't have time to go. Even that, I went back to my closet.
Tyler.
How many are
I'm just going to be making Crocs.
I love your Crocs. Speaking of Crocs, I think somebody stole one.
What?
Yeah, let's say where you're at. Yeah. You don't know where you're at.
Fail.
Okay, so they were on the floor in the locker room Friday night, and then I didn't go to the locker room because I would like to do that. And then
Check the
my dad went in there and grabbed my PE shoes instead.
Okay.
What color were your Crocs? Black.
Welcome back. What we're going to talk about today, we're going to do a couple notes on section P.7. We are going to wrap it up today. So just to let you know that, you can probably expect homework tomorrow on that stuff. It'll be due way later next week, like Thursday next week.
Homecoming
Homecoming
Friday.
but it's due next Thursday.
I remember that one.
Yeah. Hey, it's not like it's due Monday. Calm down. It's like due in a week. So you'll be fine.
Still. It's just a fact.
Oh, whatever. All right.
I expected the same.
You should expect more than that. That's what you should be. But... All right.
I expected less. I'm the same.
Alrighty.
Are you counting or?
No, I'm checking to see if they can put them all facing the same direction. Yeah, we're good. No.
Where are you supposed to close out?
What?
Where are you supposed to close out?
I doubt
Suit? Have you seen this suit?
Honestly, it looks good normal.
$4 suit from the village store.
Oh,
And it
really?
changes colors when you look at it.
Yeah, it does.
I enjoy that. You gonna cut the sleeves off? Like this?
No.
I am.
It's actually kind of nice. So I'm kind of surprised by that. It probably will never work.
Why not? I honestly didn't even go through your stuff with it.
Alright.
I know.
So first and foremost here, what we're going on to, we're on section P.7. This is on solving equations, right? This is the last day that we're going to attempt to do a couple new notes on this. Our goal today is to focus on one specific type. We're going to focus on just quadratics today. That's the idea. So we need to look at the inverse operations for those. So that's what we're going to spend our majority of our time on today. And we're going to learn a new process today that we're going to use later on throughout the chapters, like multiple chapters, not just this one. So this is a process you will definitely want to take notes on today. But again, inverse operations, the acronym that we use is SADMET. Again, it's just kind of a guideline. It's not really the exact rule you have to use every single time. But the idea is there. But again, our goal today is to touch on quadratics. And what we're going to look in quadratics, we're going to look at different approaches to solving these problems. So we're going to be looking at some where you can just factor, some where you can't factor, and then some where we're going to do a completely different process to show you kind of how we can get different answers out of it. So we're going to start with just kind of an easy one, directly from your book here. So, all right.
Can I take the problem today?
Sure. All right. Give me kind of a rough idea what I want. I want something like, okay, something like maybe 960, 162, somewhere in that range. Just something easy, and then we're going to go to the ones below it later, like 65, 66. So give me one of those.
Shall I?
Yeah, pick one.
5x squared equals 45.
5x squared equals 45?
Yeah.
Okay. All right, hey, let's say that this is our quadratic, and the goal is to solve it, find the potential values that make this thing work. I believe that all it says is evaluate the equation or solve the equation.
Solve.
Solve. So solve the equation for x. All right.
Square root property.
So all right. Yes. So we have to use. There's two methods of doing this problem. Two. There's a square root property, which is the one that they want, or there's factoring. Well, let's do factoring first. That's the one we discussed yesterday, and then we can do the square root idea, because it will eventually lead us to our next topic. So one of the rules, if we do factoring, you bring this 45 over. Right? So it's 5x squared minus the 45 equals 0. Now, why would we do that? Is because we can factor this thing apart, and then we can find potential answers to this problem. What I mean by that is, if we factor this thing apart, what do they have in common? 5. Let's pull that out first, because the 5 doesn't affect anything. So I'm going to pull the 5 out first, and what we're left with is an x squared minus 9. And then we can do a difference of squares, right? So we would factor this parenthesis apart even further to get, plus minus x and x, 3 and 3. So your potential answers here for this problem are x can equal a -3 or positive 3. Like, those are the two answers we can use that would make this thing 0. Okay? This little 5 doesn't affect anything. Would you agree that there's no variable on it? So it doesn't even apply. We can just literally ignore it. Because what I'm allowed to do is I'm actually allowed to divide it over, and what's 0 divided by 5? 0. So, like, the 5 could be gone, literally, and it wouldn't affect my problem. It's actually called a scalar multiplier. It doesn't affect my answers. I can get rid of it because I can divide it over to the 0 side. But these are the two answers. Now, if you didn't hear Cassie, her question actually asked me to do it using a square root property. So that's a completely different style of problem on this. Instead of factoring, like most people would attempt to do it like this, because it's easy, very quick, you could have attempted to do it this completely other way, where what you're allowed to do is, I'll start with the problem again, you can divide the 5 over first. Divide it over, so that makes x squared equals 9, right? And then you can take the square root to the other side. That's another potential way you could do this problem. So if I take the square root to the other side, take the power of 2 to the other side, you have to put a square root, and square roots have two potential answers. There's always a positive and negative, right? There's the principal square root, and then there's the opposite of it. And you have to list both, because they are both potentials when you do square roots. So it'll be plus or minus square root of 9, which is plus or minus square root. And it actually justifies why these are the answers, like what we said earlier. Question?
Okay, so I thought about that. I just did square root on both sides.
Oh, you
That's the square root of x
yeah.
and the square root.
That's technically what you are doing. You're taking the square root of both sides because it's a balanced equation.
Okay.
Yep. All right. Questions, comments, concerns on that round? Now, you're probably wondering, why would I want to do a problem like that? Why did I narrow it down to one of those particular problems? Because you can apply that strategy, that one right there, to a different style of problem. You can apply it to a problem that looks like this. You can apply it to this problem. And so the idea here is on this problem, instead of factoring it apart and pulling things over and doing all this math, you can just solve it like this. Yeah, divide the 3 across, making, what is that? The 4 on the other side. So divide the 3 over, makes a 4. Now we're going to take the square to the other side. So if I take the square over, I do a square root. You're allowed to do that. So that's a square root of the 4 and plus or minus, which that turns out to be, what, a 2? Plus or minus 2. And so this is what we have. Right? And then what do I do with the 1? negative 1, right? Plus or minus the 2. There's two potential answers there. Negative 1 plus 2, which is a positive 1, or negative 1 minus 2, which is a negative 3. These are your potential answers. So, do you see, like, this strategy is the exact same thing as type of that? You're allowed to do that if there's one item with a square and there's no other variables over here. You can do this little rule. The rule fails anytime you have more than just an x squared, or just a parentheses squared, like there's any other variables. Now you can't do this process. Now you have to simplify, and you have to factor, you have to come back to this route when there's more than one letter. All right, any questions with that? Okay, I just thought this is interesting. It's a quick way to do it. I mean, it's definitely a shortcut, by all means. Because some people don't see that. They don't realize you can do that. Okay, so now, what I want to talk about is this other strategy, not this, the square root strategy. I want to talk about what we do is called completing the square. I don't know if you've ever seen this in Algebra 2 days.
Oh, yeah.
It's a big topic for pre-calc. It definitely helps you solve problems. But the thing is, it's basically factoring. It's this. That's what you're doing. It's allowing you to find your answers without having to do like some crazy mechanics. Now, the reason I'm showing you now is because we needed this strategy to help you out. This has to be in place. You have to know how this works to be able to complete the square. Okay? Because otherwise you wouldn't be able to attempt these problems. Okay, so we're gonna attempt one of those. So there's no problem where they said you have to complete the square.
Okay.
Pick any of those.
Okay, x squared minus 6x
X squared minus 6x
minus 11.
minus 11 equals 0.
C.
Okay. So now, why did you ever choose to do this strategy, this idea of completing the square? Is this problem factorable? No, right? You can't break up the two parentheses to somehow make this 6 in the middle. Like, the only combination for 11 is 11 and 1. There's no way I can make a 6 from that. So what most people would attempt to do is the quadratic equation, right? You could go through and you could do the quadratic equation, which is this thing, right? It's, minus b plus or minus square root b squared minus 4ac and divided by 2a. So you could do that. This thing is what I'm about to show you. It's the same process. It's just not going directly into that. It's just doing this little simple steps so that we get the same answers. So you don't have to always plug the numbers in and waste time with a bunch of huge numbers. So here's how it works. First step, you want to get the x squared on the side where it's positive. So is the x squared positive?
Yes.
Okay, so we're good there. Okay, I'm going to move this 11 to the other side. So, because you want to get just the x's on this side. So I move the 11 over, and it becomes what? Positive 11? All right, so we have x squared minus 6x equals 11. Okay, we're comfortable with the first step. And again, this is called completing the square, if you don't know. Completing the square. So we move the 11 over first. If there is a number that's in front of your x squared, you need to get rid of it first. So what some people do is they divide whatever number's out front of the x squared, they divide everything by it. I would do that. Sometimes I'd leave it where it's at, but I would be in that camp where I would divide it first, because you're in the first couple days of doing this. Usually the number's very easy. And if there's like a 2 out here, usually all the numbers behind it are all even, so you can divide them all by 2. That's usually how it works for this first chapter. Okay, but there's no numbers, so no worries. So what we're going to do next is you have to look at the middle term. This is the middle of your problem, right? Take half of it. What's half of the 6? 3. Square it. Now, that's how you always do this problem. So we're taking half the middle squared. And that's a 9, right? You're going to add that to both sides. Now you're probably wondering, why am I adding? When you square something, what should always happen? It should always be positive. That's the idea. So we know it's going to be a positive number. So that's the process here, right? All right. We good with the first steps. All right. So we take half the middle squared. We put it on this side. This side over here should be able to factor apart. It should be a trinomial thing that you can actually factor apart into two parentheses. The other side, I don't really care about. I'm just going to add this together and makes 20. Okay, we good so far? All right. So if I break this up, this is a minus sign, x and x, what, 3 and 3? That makes the 6 in the middle. Now the reason why I know that works is because you actually set this problem up so that it will always be factorable. When you did half the middle squared, it made the perfect trinomial that you can factor apart. That's what it's doing. It's always making the terms. Now here's the shortcut. When you do half the middle squared and you put it here and here, you have to make sure you add it to both sides. That's a big deal. Some people forget to do that. And the other thing is when I break this into parentheses, here's the shortcut. What's half the middle? 3. That's what you always put in parentheses. It will always be half the middle. That's just my little shortcut for you, so you remember that. So you know what should always be in the parentheses. Even if it's a weird goofy number, it's always half the middle. Okay, now what this combines into, this is literally x minus 3 squared. Now let me explain that, why that's true. Do we agree that the two parentheses are exactly the same? When you multiply things, once again, that are exactly the same, you can literally just put a power of 2 on it. Because the power of 2, if I have like x to the power of 2, it literally means that you're multiplying something on itself. That's why I'm allowed to break this from expanded form back to exponential form. Now, why do I want to do that? Is because now this problem, what you're looking at, is that problem right there. It's the same style. So now we have something with the power of 2 on it, and we can just go through this process to actually solve it out. So it's actually pretty easy to work on. So if I move that power of 2 over, what do I have to do with it? Square root. So I have x minus 3, and I'm taking the square root of 20, which I know it doesn't work out to be a pretty number, but still works. I can still break that down. And then the last step is to move that 3 over. Now, the square root of 20, if you don't know, 20 has the number 4 and 5 in it, and the square root of 4 actually goes out. So what this actually turns into, if I move that 3 over, so 3 will move over, it'll become a positive 3. I have the plus or minus sign, and when I break down the 20, that is 2 square root 5. And this is your final answer. I don't even need decimals. I don't need anything. That is the exact answer to that problem. Notice, did I need the quadratic equation? No. In fact, this process, if you get good at it, is way faster than the quadratic equation. You don't have to memorize multiple numbers and get crazy numbers on the inside. Because most people, when they do this, they start the problem by writing this 11 on the other side. They take half the middle squared, add to both sides right away, and they'll go from here to here right away. Because they know what this is going to break up into. X minus 3, x minus 3. So they write it here, and then we can solve it right away. So it's literally just a couple steps, and you're done. It's a very, very fast process, and it works every time. It'll give you answers, no matter if they're nice numbers, if they're rational numbers. It doesn't matter. It will always work. The only difficulty with doing this is if the middle number is odd. Like in this case, what was my middle digit earlier? It was a 6, right? You take half of it, that's an easy number. And then you can square it, that's even an easier number. But there's a 5 in the middle, now it's a nightmare. Because now it just looks ugly. So in fact, I want to do one of those. I'm going to make up a problem. So, there's only 2 more problems I want to work on. This problem I'm going to put on the board, and then we're going to do one other one, which is multivariable.
So you have a problem?
Yes. So, on this one, try to pick one where that middle number is an odd.
Gotcha.
So, no even numbers. Okay, give me one.
3x squared minus 3x minus 4 equals 0.
Okay,
4
second.
minus 4.
Minus 4, back here. Sorry. Okay, we good? Okay, I agree. This is good. All right. So, first step. The same exact process over there. You could go to the quadratic equation if you wanted to. This thing, I do not believe is factorable. It doesn't work no matter how you try to break it up into parentheses. Because if it was factorable, I wouldn't need to do this whole cracking process. So the first step, let's move the 4 over to the other side, so I have this. So I move the 4 over. Okay, we go to the first step. Now, second step, is there a number in front of my x squared? We have to get rid of it. You literally have to divide the number in front of the x squared off. So we're going to divide everything by 3. This is where it becomes ugly. Because now, when I divide this by 3, that's an x squared. Divide this by 3, that's a 1. And then divide the 4 by 3, and I have to leave it a fraction because that does not work on mention 3. In fact, I would leave it a fraction. Don't make it like a mixed number. Okay, questions, comments, concerns so far on the starting point. You have to get the x squared by itself for this process to work. Otherwise, you can't break it up into perfect squares. Okay, so now that we're here, now we're going to do the same process we did over there. Because I got the x squared by itself, I don't care what's on the other side. What's half the middle?
45.
Yeah, it's half, right? It's literally just this number over the number 2, right? That's how you cut it in half. But we have to square it. So squaring a half is a fourth. Because I'm taking half the middle, and squaring it, you have to square both numbers. So it literally turns out to be a fourth. Here and here. I have to add it to both sides. Okay, does everyone see where I got the fourth from? Just half the middle, which is literally the number half squared. Okay, now, we're going to factor this thing apart. Okay, because this side's ready to go. That side I need to get common denominators on. But this side I can actually factor into 2 parentheses. Here's a shortcut. It's going to be minus minus because of the minus sign, x and x. And what's half the middle? That's literally goes here and here. It's always half the middle. Because those numbers will multiply to give you the 4. I know that's my little shortcut for how I can always tell you how to factor that thing apart. It's always whatever half the middle is, if you did this correctly. Okay, on the other side, we need to add those together. What do I need to do to add those together? Common denominators. Yay. So this is, I'm going to do this off to the side. So it looks like I'm going to have to get 12s on the bottom. So I have to multiply this by 4 by 4, multiply this by 3 by 3. So this turns out to be 16 twelfths plus 3 twelfths, which turns out to be 19 twelfths. Not a pretty number. Okay. Did I lose anybody? I'm going really fast. I'm so sorry.
Hold on a second. I'm trying to make my stuff.
Okay. We'll take it a little break.
Sorry, I comprehend phone time.
No, that's not. No. If I go too fast, you gotta slow me down. We are in no rush today. All right. Everyone's still following with me? I haven't lost anybody yet. Majorly anyway. Okay. The next step, I'm going to combine these down to make the 1 parenthesis. So what do I need to put on that 1 parenthesis? Square power 2. There's 2 of those parentheses. They're exactly the same. Okay, so x minus half squared, and then the 19 halves, or 19 twelfths. That is just ugly. Don't like that. All right. And now we can solve using that process. This is where I told you, like anytime there's an odd number in here, now it's a nightmare. It's a nightmare of fractions and understanding where to go and how to solve this thing. It's just, oh, it's ugly, ugly, ugly. But we have to keep going. We have to continue on here. So I'm going to take the half to the other side, doing the square root idea. So I'm doing the square root. X minus half. Taking the square root to the other side, which is square root of 19 twelfths. And I have to simplify that down.
We're down here together.
Oh, okay. So just don't hit the chessboard, please. All right, bye, gentlemen. Okay.
What are you that for?
No idea. One's not mine. All right. Okay. All right. We go with where I went to so far. Okay. So we've taken the square root to the other side. We have the plus or minus sign. Now the problem is we can't leave it like this because you can't leave the square root on the bottom. Technically, there's a square root of 12 down there, which is terrible. But we have to get rid of it. But I'm going to move the half over. So technically, this is your answer. It's half plus or minus square root of 19 twelfths. The problem is you can't leave the 19 twelfths. To get rid of the 19 twelfths, you have by the root 12, because it is a root 19 over root 12. I mean, this is literally what it is. Root 19 over root 12, so I have to multiply by root 12, multiply by root 12. So the bottom just turned out to be the square root of 144, which is 12 on the bottom. And the top, if I don't simplify, because I know you can simplify 12, but if I don't simplify that, 12 times 19, what is that? It's literally 240 minus 12. 240 minus 12 is 228. Does any of the calculator? Yeah, it's a terrible.
I bet we got those in our
We got
homework.
something on 19 times 12. So 228. All right. We have to leave it like that. Now, I know 228 can be broken down further. I don't really care about it right now because it's not on the bottom, so it's not a big deal. But we don't have square on the bottom. You agree? Nightmare. It's ugly.
Are we gonna have those on our homework?
Eventually, yes. Eventually, yes. I mean, eventually, yes, you will see a lot of these problems. Like, this will become second nature to you. This is just a process we just do in the middle of problems, middle of chapter 2, chapter 3, chapter 4, because those problems will ask you to solve polynomials. We're looking at a graph and we're trying to figure out what problems, because what this is giving you is where we hit the x-axis. So this is a potential answer where this graph crosses. There's two answers. So that's just something we're going to eventually get used to. This process of completing squares is used in circles, it's used in hyperbolas, parabolas, all this conic section stuff. It's used in linear problems. These are conics. These are curves. Quadratics. Okay. Questions on this? Okay. Last problem of the day. I'm going to end with an easier one. Easy problem. Okay. I'm not going to do one of these completing squares.
Do I just keep going down a section?
What was that?
Do I just go down a section to give you a problem?
No, I'm just gonna make up one. The book doesn't really have good variable problems, so I just want to make up something. All right, so let's go with A equals BC minus CD all over E, and I want to solve for C. Using capital letters. All right, so this is one of those multivariable problems. We have multiple letters on this problem. I'm just making up something. I could pick something obviously from the book, but I think those are good ones. All right, the goal is to get letter C by itself. Now, here's the problem. When most people look, they get confused because there's multiple letters in this thing. Really, the way to think about this problem is you just rearrange it. You're just kind of moving stuff around, but when you rearrange, you're using the correct math, right? So you're using inverse operations. So, like, for instance, I know if I need to get the letter C, because that's what I'm trying to solve for. I'm trying to solve for this letter by itself. I need to get rid of anything that doesn't have a C on it. So, like, for instance, I need to get rid of this E. How do I get rid of the E to the other side? Multiply. That's an inverse. That's correct math. So you're going to multiply the E across, so we get AE equals BC minus CD. Right? Does that make sense? Like, we multiply the E across. Let's just rearrange. It's not really doing anything crazy. Now, on this next part, I need to get the C out, right? If you notice, there's a couple letter C's, and I'm trying to solve for it. So I'm going to factor it out, because that will just make one of them if I pull a C from both of them. So if I pull a C out here, what I'm left with is, if the C's come off, I'm left with B minus D. Because that's literally doing inverse, inverse distribution, which is called factoring, or not common factor. And then the last step. Yeah, you take this and you divide it over. Now the reason why I know you divide it is it is multiplied on the C. So I'll divide that mess over. So it's AE divided by B minus D. That is your answer. That's something that I know is difficult for a lot of people. Because the people who are going to be successful at this are people who are really comfortable with their math, like their inverse operations. They understand when you need to multiply, when you need to add, when you need to subtract, when you need to factor, that type of thing. People are not the people that don't understand which rule comes first. Those people will not be successful at multiply variable terms. Okay. Questions, comments, concerns? Done for that. About 10 minutes. for my own knowledge. Do I turn this or no?
Well, he's gonna put it.
Work it, work it, just right now.
This is a normal day, you go there whatever lunch you want.
Yeah, I know. That's part of the
Fine. You have to do it in front of the whole class, though.
Wait, do what?
Take a picture for the year. Nick, do we actually get a girl grab? Do we get a girl grab? Our class? Well, we're
What are you guys doing?
who else will do
Dude,
it?
what are you doing?
I feel like I'm comfortable, so that really helps.
Because the seniors are grilling right now. They grill before school. Next year, you can
When?
Because someone told me I was student council's job. I'm like, I don't know what you're talking about. This is a cliche, this was
what?
Dude, Miss Sash is so good.
What do you ask that?
He always tells me that. Wait for you. Can't go there and not do it.
Actually, we did have a pop.
Yeah, you do,
This is the easiest thing ever. Good luck. I got 85%. Yeah, what did you get in comic books?
You got 84.
I got 85.
85%.
Yeah, no, they're great. That's fine.
I
I got a B plus there though. I got
Yeah,
check.
I
I just swear I heard it.
I literally,
An 83?
Sure, we got a 59. He said, yeah, this is what he told me. He goes, I missed a lot of them on purpose because I figured that if I just get like a 60, I would be able to retake it. So I might as well try to fail it so I can take it. So what did you get again? 59. So we can barely.
You barely.
See, I thought about that. What are the facts I got? Like, you got like a 60. Yeah, that would be awful.
Try to get Edwin. Try to get Edwin.
I have nightmares about that.
You can be able to get Edwin.
I have nightmares about that.
Yes. I think if you get those, you'll get like 30% and you're about to get A student.
Yeah.
I think she'd be able to tell you, she was like,
Or 0%. I'm like, alright, I guess everyone else, I guess everyone right.
Level on here, right?
Oh, actually,
literally just told you. You get your test back, by the way.
Hey, look, quiz in American history.
Alright, this is that one.
You started it.
Or did you see
That
this?
is over on
What's that?
Hey, you still have that thing there? Oh, okay,
Yeah, but- See, I don't wanna go right away.
I don't know. Oh, I probably.
You should probably get that.
I knew that Google's, they've always they've been excellent.
Yeah.
They've never done. The problem is that what hurt me the most is Samsung.
Taylor.
See this too? People are drilling.
Show me there. Yep.
Because
Because people are gullible.
yeah, because someone there was like a thing on there that said that the iPhone jack is still there, but it's just going out. So then people have been trying to drill on their phones.
That's like dumb.
I just congratulations.
Yeah, it's definitely not there. That's, they put the force touch haptic feedback on it. And they put a second speaker, so.
Wait, don't you have yours?
What?
You gotta flash two.
Is the camera the same?
It was good. They haven't released the update yet for when it can do the blur effect, which I call like where when you take a photo, it can like crop what's in front from behind and it can blur the background.
It's still in my
Really?
Like usually when you do that in like really high-end editing photos after you like you outline your subject and then you place a blur in the background, right? You do it post back. The iPhone will eventually be able to do it on the fly.
That's awesome.
Where when you tap the screen, you focus on like where your subject,
What?
it'll separate it from the background and blur it away.
Yeah, that's cool.
And they've been showing it in the betas that because it's supposed to come out this fall, and professional photographers say it's one of the best blur things they've ever seen, especially with the camera already doing it before. Because no camera's ever done this before. So, and the reason why they can do it is they have two lenses. So one will pick the background, one will pick the foreground, and now they know how to separate it.
Does the normal one only have one camera?
Yeah.
Yeah.
This is one.
The other thing I was thinking was just a limit to.
And the funny thing is, because I didn't know if they were going to pull the trigger on the two cameras, because one was that they weren't, it's slow down. If they didn't, I was just going to get subs. I was just going to get small ones, get a long storage. But they pulled the trigger on the actual dual camera.
Eventually the 8 is going to be way different.
Yeah,
Like the 7 is
I
kinda
think they
similar.
said that they're going to try to move to a full body screen on it, which I like the idea of that because the chin and forehead are kind of big on it. So I like the design. I really like the profile of the filmmaker. The matte black is actually really pretty. If I wasn't into gold, I would probably get that one.
Well, he said that, you know how his was like, there's a scratch on it or whatever? There's been a lot of jet black ones that had to get like reset back because it's so hard to get that color, I guess.
It's when it goes down the assembly line, literally the rolling pins can scratch it because it's just that sensitive. So they always say like if you get one of those, you have to buy an invisible film to put on the back to prevent that. Which I didn't want to do that. So my phone's gonna get beat up. I don't put casing on it. I know it's gonna have wear and tear, but I like the aces. So
Finding.
Everyone loves a good age phone,
I
huh?
like it. Yeah, it's character. Your phone's got some data. Not cracks, but I hate that.
You want dents on your phone?
My screen's falling out. I dropped it.
It shows that I
Don't mind. I'll trade you. Oh, are you kidding me? This thing's in great condition. Got a few, it's got some character on it, but I don't know.
I've seen the iPhone 7s. They've lasted on a couple of years. So it's fine. I was by Apple. And eventually I'll get the tempered glass. Not you're lying. I have ordered it. Like they do. The website wasn't allowing me to order it.
And I like your
Actually, that's just
Where are you still trying to get all that?
Today we're on all over your monster. Oh!
I went back to art shows. You have to really shake his head.
Well, the first time I did it,
Yeah.
but I went to Wisconsin, but then
I have
he was
one. So I just got
What? Are you doing tug of war? No. You already signed up. Yeah, you signed up. I read on your week.
They call my name.
Hello?
someone just told me that our Hollywood was too cute. Okay, what's that about?
You can repair stuff that's in the phone. Add stuff.
I didn't they're always good. Hey, what's this?
Repairing is in the rules, you're allowed to do it.
Yeah.
You just can't add stuff. And they thought you were adding stuff.
No, I'm just calling.
And that's in the rules. I'd actually read that.
What, the rule book? I want to see the rule book then. I've asked for this rule book several times. They never give it to me.
You don't look at it.
I want to see the rule book. I'm American. I'm right for that.